Okay, so today we're going to get started on section 10.3, which is congruent chords and arcs. So remember that a chord is a segment that connects two points that are on the circle. So like in this picture here, AB would be an example of a chord and CD would be an example of a chord. Okay, so let's use some theorems. Two chords are congruent if and only if their corresponding arcs are congruent. Okay, so for an example here, chord AB is equal to chord CD if and only if the measure of arc AB is equal to the measure of arc CD. Okay, so let's look at that in the picture. So they're saying that AB, and CD are congruent if this arc is equal. Well, that makes sense, right? Like if the portion of the circle is equal to this portion of the circle, then those segments have to be congruent. Okay, another theorem is they are equidistant. Ooh, what does that word mean? What do you think it means? Let's look at the word. Distant means distance. Equa means equal. So equidistant means equal distance from the center of the circle. Okay, so in this case, again, we're talking about chord AB and chord CD. They're equal if and only if EF is equal to EG. Okay, this makes sense. Like, look at our picture. Okay, again, so AB and CD are equal if they are the same distance from the center. Okay, if EF and EG are congruent. If a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. Okay, so let's look at what that means here. All right, see how EF is perpendicular to AB? That means that cuts the chord in half. Okay, and it also cuts the arc in half. Okay, so how do we write that with math notation? Since EH is perpendicular to AB, then AF is equal to FB and measure of arc AH is equal to the measure of arc HB, which is what I just drew on the picture. All right, let's use this information to do some math here. Okay, so first thing we're just going to do is to find x. Okay, so see how the chords are equal? Since the chords are equal, that means the arcs have to be equal. Okay, so that would, you set them equal to each other. 7x plus 24 equals 115. And then we'll solve that. Subtract 24 to get 7x equals 91. Divide by 7, x equals 13. Done. Okay. Take a look at number 2. I'm going to have you do number 2 on your own. Okay, but just a quick talk about it. See how the arcs are equal? Since the arcs are equal, that means the chords have to be equal. Go ahead and solve for x. All right, we always go a little bit further. And the next one, okay, so again, the arcs are equal, so the chords have to be equal. So we're going to set these two equal to each other. 9x minus 34 equals 4x plus 1. We're going to solve that. 5x minus 34 equals 1. Add 34. 5x equals 35. And so that when I divide by 5, I get x equals 7. But that doesn't ask for x. It asks for xy. So we're going to plug it in. 4 times 7 is 28 plus 1. Xy is equal to 29. Okay, number 4, trying to find measure of arc RS. Again, we're going to set them equal because the chords are equal. 5x plus 6 equals 11x minus 72. And everybody knows how to solve that. You guys are great at solving equations. Okay, and then when you plug it in, we're finding the measure of arc, RS. So it would be 11 times 13 minus 72. Okay, when you do that in your calculator, you get 71 degrees. All right, now number 5 is just a little bit different. Okay, because, we can't just do the same thing all the time, right? Whoops, sorry. Okay, sorry. Okay, so we have ZY. ZY is also going to be congruent to XY. So I'm going to go ahead and write that on there. 6y minus 20. Okay? Then we talked about last time that all the degrees in a circle add up to 360, right? So I could take 6x minus 20 plus 6x minus 20 plus 76, and that should equal 360. It's a whole circle. 6x minus 20 plus 6x minus 20 plus 76 equals 360. Okay, so it's going to be 12x, and then that's going to make, let's see, plus 36 equals 360. Subtract 36 from both sides. 12x equals 324. Divide by 12. X equals 27. We get to stop there on that one. All right. So that's that. Let's take a look at number 6. Okay, number 6 says MP is 5x minus 34 and PN is 2x minus 4. Find MP. Okay, so let's look at this picture and see what we can notice. Do you notice how the arcs are equal? Since the arcs are equal, therefore the chords are equal. Now, if the chords are equal, then they have to be equal distances from the center. So what does that mean? That means MP and PN are congruent. So we're going to set these two expressions equal to each other and solve. So 3x equals 30. X equals 10. We're not done. It wants us to find MP, so we'll plug that in. MP is 5 times 10, that's 50, minus 34, which is 16. All right, let's look at the back page. All right, so let's see what we got here. We've got DE and FG, and we're trying to find DE. Okay, do you see how they are equidistant from the center? That means they have to be equal to each other. Okay, equal distance from the center means they are equal to each other. So, actually, I'm going to go ahead and have you find this one on your own. All right, number 8, we've got these are equidistant from the center, which means the chords are equal, which means the arcs are equal. So we're supposed to find MP, but we're going to start out by just setting these arcs equal to each other. So 9x minus 43 equals 5x plus 33. 4x minus 43 equals 33. Add 43. You get 4x equals 76. So x equals 18. Okay? Now, let's just plug that in here. 5 times 18 plus 33. Okay? So when you plug that in your calculator, 5 times 18 plus 33, you get 123. Now we said that the arcs were equal. So this one also has to be 123. Okay, so if I want to find arc MP, I'm going to take out from 360 these 123s. Okay, so 360 minus 123 minus 123, the measure of arc MP is 114. Just let me check my math really fast. Oh dear, I've made a mistake, haven't I? Just a little one. Let's go back and fix that. Okay, when we divide by 4, we actually don't get 18. We get 19. So when we plug it in, we get 128. Okay, so 360 minus 128 minus 128 is 104. Okay. All right, so we're going to find some measures now. Okay, hopefully these won't be too bad. Let's see. In a circle Z, okay, so remember we named the circle with the center. Okay, it says RS is 18. Okay, RS is 18. TY is 42. So I'm actually going to label that one. This part right here is 42. Find each measure. Okay, so if we're finding TV to start with. Okay, if RS is 18 and it's equidistant from the center, then TU is also 18, which means TV has to be 9. We just said TU was 18. Okay. WS. WS. So RS. Oh, RS is 18, so WS has to be half of that. So that's 9. Okay. We know that this is also going to be divided in half, so YU is going to be also 42. And then the arc here, this whole arc would be 84. And so the whole arc of RS would also be 84 degrees. These 200 degrees. Okay, let's do number 10. We have circle I. Okay, so we'll see what we have here. We have some congruent, equidistant from the center. These chords are equidistant from the center and they're perpendicular. It says BG is 17. I'm going to write that in. And CHA, that's this whole arc over here, this big arc. Remember, more than 3 letters is more than 360. I'm sorry, more than 180. Okay, and we're finding each measure. Okay, so we're going to start with BC. So if BG is 17, then BC is going to be twice that. So it's going to be 34. And then FB is going to be congruent to BG, so it's 17. Now we're going to look at the arcs. Okay, first we're going to look at arc AB, and then we're going to look at arc BC. Well, those are actually equal, aren't they? AB and BC are equal. So that's what we'll do for those two, is we'll take 360, we'll subtract out 256. Okay, let's see what that is. 360 minus 256. Whoa, what was the multiplying? Okay, minus 104. And then we'll divide those by 2 because they're 2 equal. So that's 52. So these are both 52 degrees. Okay, and then for measure EC, that's going to be half of that 52. Okay, so that's 26. All right, let's take a look at this one. It says QM. Where's QM? QM is right here. QM is right here. Okay, and MR. QM and MR. Well, they're going to be equal because these are equidistant from the center and perpendicular. So all of these parts are going to be equal to each other. Okay, so we're going to set them equal to each other. Okay, so 6x minus 11 equals 2x plus 9. So 4x minus 11 equals 9. 4x equals 20. X equals 5. Okay, so what are we trying to find here? I'm trying to find MN. MN. So here, I'm going to go ahead and put it into MR, my X. I'm going to put into MR. And then I'm going to multiply by 2 to find this whole distance MN. Okay, so 2 times 5 is 10, plus 9 is 19. And so MN is going to be 2 times 19, which is 38. Okay, number 12 involves our arcs. Okay, so CI is 7x minus 15, and EF is 12x minus 8. Find CI. Okay, so let's see what we got here. We got equidistant from the center. We got perpendicular. So we know that each part of these arcs are congruent. Okay, so it said that CI was 7x minus 15. Okay, that means that ID is also 7x minus 15. Now then it says that the whole arc EF is 12x minus 8. So these two parts, these two 7x minus 15s, are going to add up to be equal to 12x minus 8. Okay, so 7x minus 15 plus 7x minus 15 equals 12x minus 8. Okay, so 14x minus 30 equals 12x minus 8. And we'll solve that. You guys all know how to solve this. So x equals 11. All right, now we're going to find CI, so we're going to plug that back in. 7 times 11 is 77, minus 15. The measure of arc CI is 62. All right, good. All right, so we're going to use the same picture for 13 and 14. We've got VW. So VW, trying to find that. Okay, so see how we're going to have to use a Pythagorean theorem here? That doesn't go away, guys. We've got this right angle here. We've got the hypotenuse is 13. So we're going to find this side. Now, this is actually a Pythagorean triple. Okay, so this is one that I have memorized. It's probably a good idea if you have some memorized as well. So when I subtract, I get ZW squared equals 144, so ZW equals 12. Okay, so this is 12. That means these are congruent, so this is also 12. So VW is going to equal 24. Now, we're going to find YW. Okay, so if you remember back from the previous section, we said that central angles are the same measure as their arc. So I need to find this angle right here. What? I need to use some trig. Remember trig? Oh my goodness. Okay, so you can use any trig function you want. I'm going to use cosine because I know that this 5 is the adjacent side and this is the hypotenuse. So I'm going to say cosine of the angle was, we'll just call it angle x, cosine of x, equals the adjacent side over the hypotenuse. And I'm going to take the inverse cosine of both sides. Okay? So when I do that in my calculator, remember that inverse cosine, second cosine? I get that that angle was 67.4 degrees. So that means that the intercepted arc, that measure of arc YW, is also equal to 67.4 degrees. Okay, pH. Let's see what we got here, see if we can label anything. We've got HK. HK is 30. That means each of these are 15. I'm going to mark those in, 15 and 15. And PM is 8. So that means this is 8 and this is 8. Trying to find pH. Okay, so we're starting off by finding pH. Now, I'm going to outline this in green for you, this triangle here. Do you see how that's a right triangle? And I know two sides. So I want you to do number 15 on your own using the Pythagorean theorem. And then number 16 is very similar to number 14. Okay, so we're trying to find GJ, this whole arc. So I could find this angle right here using tangent. So I'm going to say the tangent of x is equal to the opposite side is 15 over the adjacent side is 8. And I'm going to take the arc tangent or the inverse tangent of both sides to give me, when I do that in my calculator, second tangent, 15 over 8. That's going to be 61.9. Okay, so that means that HJ is 61.9, GH is also 61.9. Okay, so when I add those together, the measure of GJ is 123.9.